Okay, good afternoon. I'm John McGowan. I'm currently chair of the CitA Board of Directors. I want to welcome you to CitA's Technology Trend Series, whose overarching goal is summarised in the slogan, "It is about time, cost and quality." We have three very experienced speakers today whose seniority within their international services company make them particularly qualified to speak to our series theme. We have a lot to get through, and to finish on time. So without further ado, I will hand over to our first speaker, Robin Evans from Arup. And just I want to comment, if you could, we're going to hold questions until the end of the session. So if you could put them into the chat box, we'd appreciate it. Over to you, Robin.
Great, cheers, John. Just going to try and share my screen. Can you see that?
Yes.
Excellent. Okay. Thanks very much. My name is Robin Evans. I am a senior mechanical engineer and BIM consultant in Arup. I'm normally based in our Dublin office, and I've been working in the building services industry since about 2006. Been lucky enough to have had the opportunity to work on a huge range of different projects over that time. I recently got my BRE global certification for ISO 19650 Project Information Manager, and I have a great interest in BIM and especially focusing on engineering design automation. I'm the mechanical automation champion for Arup in Ireland, and I've also recently joined the ACI BIM committee. So my presentation today is titled Overcoming Common Obstacles to Achieve Project Efficiency Using BIM. So let's start with, what is BIM and why do we use it? BIM is something that's been spoken about in the construction industry for many, many years. The benefits of using BIM, the advantages that it will provide for all project stakeholders, the efficiencies that it allows while adding more cost certainty and improved visual outputs, which can be used for things like virtual reality and augmented reality and so on. But in this presentation, I'll be asking, are we really seeing all of these benefits being realized on the majority of BIM projects? The advantages of BIM are certainly real and attainable, but I'd like to look at some of the common reasons why some BIM projects are not as efficient as they could be, and investigate how we as an industry can change that. I'll be exploring how we can use BIM to reduce abortive work, which also reduces cost, and how using the correctly built BIM model for automation can save time and improve quality, which also reduces risk, leading to better cost certainty. I'll just note that this is obviously based on my own experience and won't be the same experience for everybody or for every project, but I thought it'd be useful to share. So some common misconceptions. BIM is a software. BIM is a 3D model. BIM is a new concept. And BIM saves time and money. So the BIM facts. So BIM is actually a process. There's lots of people still talking about BIM and technicians exclusively, like in the CAD draftsman days. Arup say that building information modeling is a descriptive term for technologically advanced, digital, collaborative, and information-centric processes in built environment design, construction, and operation. This means that all project stakeholders should be involved, which unfortunately is not always the case, and this can impact the overall potential benefits of BIM on the project. So secondly, BIM is a 3D model. BIM uses 3D models as tools that form a part of the BIM process. These models can be used to store project information and display that information in a range of ways, including 2D drawings, schedules, 3D views, and so on. BIM is a new concept. BIM has standardized existing, mature, and well-defined processes of project management. And the recently, 2018, published ISO 19650, as well as its predecessor, PAS 1192, has helped to progress this even further. BIM saves time and money. I guess, yeah, just to be clear, BIM has the potential to achieve significant savings in terms of time and money, but this is only possible when the correct BIM process is followed and the BIM requirements are clearly defined and developed to suit the specific project and client needs. And conversely then, BIM also has the potential to add significant cost if this is not done. So what are we meant to be getting out of BIM? Amongst a whole lot of other benefits, and in my case, mainly focused around MEP, some of the benefits we are meant to be getting are time savings, automation of design, better coordination, improved cost certainty, realistic visualizations, and really using the BIM model as the central database, which is of course what Revit actually is, for producing 2D and 3D drawings, schedules, equipment data sheets, visualizations, bills of quantities, and so on. But what are we actually often getting out of BIM is disconnected information coming from multiple sources, which may lead to inconsistency and risk of error. So although a lot of companies are embracing well-developed, efficient BIM workflows on many projects, there are still some projects which are not realizing the full benefits of BIM. And this can be caused by things like I'll go through on the next slide. So I'll start with an issue that we see as quite a serious risk when delivering a BIM project. Basically, there's no such thing as one BIM. It can mean many different things for different people. And it's really important to agree at the outset of your project what it is supposed to mean in your case and on your project. We often hear people talking about level 2 BIM or BIM to ISO 19650 as if it defines the scope of the BIM model. It doesn't. It does do a great job of mapping out the process, but it doesn't set the requirements. It can also be seen in what is sometimes referred to as academic or theoretical BIM versus practical BIM. And this is where we see an appointing party asking for all of the bells and whistles that BIM can possibly theoretically provide, like masses of parametric information or very high levels of graphical detail, without thinking enough about what they will actually use the model for or what the value of what they are asking for will give them. And also the issues that this could cause, like slow running models due to very large file sizes and so on. And then probably the most common cause of BIM efficiency is projects that use Revit for CAD, not Revit for BIM. And what I mean by that is that we have the opportunity to use Revit to create very efficient BIM processes and yield amazing outputs. But often, and for various reasons, we try to fudge parts of the traditional engineering and construction workflows into a new digital BIM workflow, which just isn't productive and often results in unnecessary doubling up of work. There are, of course, luckily, lots of ways that we as an industry can overcome these problems. So if we take the three issues that we looked at, firstly, one of the best ways to reduce risk on any project and to ensure that the client gets maximum value is to clearly define the scope of work and write that down in as clear a way as possible. And that also needs to happen in BIM projects. The appointing party should share a clear project-specific scope of works in sufficiently detailed documents, especially the EIR and AIR, which should set out exactly what the client is expecting at each project stage. I also think that avoiding any kind of generic requirements or sentences like the model may be used for and so on would really help. BIM has provided amazing opportunities for delivering large amounts of information, but just because we can do something or have something, it doesn't mean that we should ask for everything. We need to use lean methodology to ensure that we adopt a BIM process that will benefit the project without imposing additional or unnecessary work on anyone, because this just results in waste in terms of time, cost, program, and so on. And then we look at Revit for BIM, not Revit for CAD. I flipped it around the right way there. So like I said before, Revit is a database, and in order to maximize the benefits of BIM, we need to input machine-readable, structured information into the elements in our Revit models. Using parametric information instead of using traditional workflows which use dump text and disconnected systems will enable design automation and parametric modeling. It really doesn't take much longer to put the information into the correct place in the Revit parameters, but this will lead to huge efficiency benefits on any project. The whole concept of BIM revolves around leveraging the information which is input once into a model and can then be used many times for many applications. Displaying figures and information on drawing tags, calculating values in other parameters, producing schedules, and so on, all from that same information. If we as an industry become more aligned in our approach to how we set up and deliver projects, with more of us using effective workflows, we'll improve our developments in automation and project efficiency. So mapping our digital workflows is something that we've been developing in Arup over the past few years, and it's something which provides so much potential, especially when that same workflow is being followed globally. This has been successfully implemented, of course, in lots of industries to standardize processes, and it's a really great way to easily identify inefficiencies. ISO 19650 also has lots of small examples of workflow maps which help to describe a process in a visually easy to understand way. And here you can see an example of one of our workflow maps. The one on the left, it's a high level one for the overall hydronic system designed for heating and cooling. And we've looked at what tasks happen at different work stages, and we've mapped out the plan that we follow, what the requirements are, and the tools or scripts that we use to most effectively complete our deliverables. And these workflow maps can then be broken down to a more granular level for more complex tasks or processes which have multiple layers. Another really important consideration in making the best use of BIM is structured data. So using structured data on our projects is key for digital efficiencies. And this isn't just related to Dynamo scripts or Revit tools, but that's obviously really important. We're talking about digital information as a whole. For example, if we structure our Excel sheets in the same way using the same standardized template for all of our calculation sheets, we'll be able to harvest design information much easier in the future. I often wonder what we could learn, what trends we would discover if we were able to harvest and analyze all of the design information which is embedded in our previous projects. And all of this is possible, but we need to start at the start and get those basics right. A great saying that I heard recently is the best time to structure your data was 10 years ago, and the second best time is now. keeping the possibilities, including future possibilities, in our minds as we set up new Excel worksheets or Revit projects in our BIM processes should help us plan for even more efficient workflows as we move forward. It's really great to see some standardized guidance being developed for our industry. The draft issue of the RIAI BIM pack looks really promising, and I'm sure it'll help us all to achieve better project outcomes by following a standardized approach. ACEI have also published some great BIM guidance, which I know has been updated to align with ISO 19650 and provides information on the industry agreed approach to delivering BIM projects. And I can share the link to the existing ACEI documents in the chat when I finish. I thought I'd finish up with a quick look at what is possible when we do engage ourselves fully in these new workflows. We can involve our clients in really captivating immersive technology experiences like virtual reality and augmented reality and so on. The image on the left there is our new immersive technology space called the Hive in our Dublin office. And the space had really great feedback from any clients who've used it. We can then progress that immersive technology experience to allow our clients to visualize specialist sliding designs that you see in the two images here. And then we can produce really realistic photographic Matterport scans that we can view something like this utility tunnel, and the little close-up there on the right, where everything, where we can see exactly where everything is and how things are constructed, even when we're off-site. So we can do virtual walkthroughs and so on, even when we're not there. And this is really useful, especially for hard to access areas. We've got a look at some really nice high level renders, which really help all of our stakeholders easily understand our designs. And finally, then, if we do put all of our information into our models in a structured, machine readable way, we can leverage that for things like the parametric modeling examples on the left, which assess thousands of design options at the click of a button, or automating repetitive tasks by using Dynamo scripts like we see on the right. That's me. Thanks very much. And I guess, like John said, any questions, you can put them into the chat, and I think we'll be answering those at the end of the session.
Thank you, Robin, and well done on making the time.
Thanks, John.
Milestone. Gearoid, it's now over to you.
Okay,
Gearoid,
thank you, John. I just set up my screen so that you can see it. Okay, so you can see my screen now?
Yes, we can.
Perfect. Okay, so thank you very much for that, John. Great presentation there by Robin. I think what I take most from it is using BIM using Revit as BIM as opposed to using it as CAD. And I think Robin has kind of outlined the, I suppose, dare I say, frustrations that are out there, or the obstacles that are out there at the moment, in terms of we know where we want to go, we know the information that we can derive from, we just need to join the dots as such. And I suppose what this presentation is hoping to do over the next 15 or 20 minutes is kind of give an idea of the integrated workflows that we are kind of bringing in as a company with Linesight to try and hit the targets of time, cost, and quality. And throughout the presentation, I'd look to give you insights into the workflows that we're currently implementing within Linesight. I mean, it's at the end of the day, it's not an exhaustive process, and I'm sure Robin will agree with me as well, is that whatever processes they are coming up, you're always trying to learn, you're always trying to get new ways of doing things and improving the overall elements of it. So in terms of the agenda that I will look at today, I will look at kind of the collaborative BIM approach. I'm fairly certain that most of the people on this call are fairly au fait with BIM and the kind of basics of BIM in terms of dimensions and stuff like that. I want to kind of look at it a little bit further and, touch on the obstacles that Robin has just kind of outlined there a few minutes ago in terms of us not working in independent silos. So we need to work in a more collaborative approach. Gone are the days when the QS takes all the information at the tender stage in terms of drawings and specifications. It does up their cost estimate, and it's almost like a race at the very end to try and get the information together, trying to issue new drawings and specifications to marry in with it. I think if you want this process to work, if you want this BIM process to work, you need to define exactly what you need to do for each step of it, as Robin kind of alluded to in his presentation. And you also need to follow through on them and come out of your comfort zone to a bit of a degree where, 5D obviously would be the cost management, which would be the core business group of Linesight, but that you need to be able to be confident to run into a little bit of 3D if needed, because we need the information. We don't create any design information. We digest the information that's coming out in the model. So we need to have the ability to go into the 3D area where the design is taking place and communicate and to have a conversation with the designers, architects, engineers, M&E people that tell them, well, this is exactly what I need and this is the format that I need it in, and please provide it in this information, and write it into those documents that Robin was talking about in terms of the ISO 19650. Write it into the EIRs and the BEP plan so that everybody is fully on board with it and fully up to speed with it. The second part of the presentation, I'll delve a little bit deeper into time, cost, and quality in terms of what we are doing. I'll touch a little bit on the time and the quality aspects and maybe go a little bit further then on the costing side of things. I'll bring you into worked examples. I have a few videos that I will show you in terms of the workflows that we are looking at, getting the quantities out, streamlining the quantities through the likes of model maps and QSID codes, which will ultimately feed into an automatic workbook or an automatic cost estimate. Again, I'm not claiming it is the be all and end all in terms of processes. It is worked through Costex. There are other softwares out there, but it's just the workflows that we're working on at the moment. And as I said, this is an evolving system. BIM has been around for a good number of years. It is constantly evolving, and you can see throughout the presentation the evolution that has taken place in terms of, if you look at, we'd say even 10 years ago, it used to be a case that models were brought in and they were a nice to have situation where you go away, you try and find a few quantities, you might get a complex shape and that will give you the surface area of it and you might use it as part of your estimate. Whereas I think now it's beginning to change, notwithstanding the obstacles that are still there in terms of getting the right information in there and get everybody on board with the workflows. But I think the ideas are changing, that BIM has now become to the forefront. The models that we are getting, we're starting to work on projects where BIM is the driver of quantity extraction and all other processes as well, rather than just being the kind of supplementary tool that we use to validate. We're starting to see situations where the primary quantification is being done through a 3D model, and then the 2D kind of elements are there as a backup check for you to look at. Quick introduction to myself before I start into the meat of the presentation. So I joined Linesight in January of this year as a regional BIM lead, and together with my colleague Cathal O'Donnell, unfortunately couldn't be here today, our remit is to implement BIM processes within Linesight to meet the changing nature of how projects are delivered in the construction industry. So, test all the software that's out there and really kind of come up with innovative BIM processes to integrate into the standard workflow within Linesight to meet the challenges that we are facing at the moment, because more and more clients, as I said, are looking to have this as ubiquitous within the project deliverable. So in terms of a collaborative BIM approach, we've all seen these dimensions. 3D, 4D, 5D are the main stock dimensions, and kind of they bolted on 60, 70, 80, and I'm sure they, as time goes by, they will add on other ones as well. So from a Linesight perspective, we obviously have a lot of work in around the 4D, 5D elements, and also on the safety, embedding emergency plans and safe work plans and stuff like that within the model. But I suppose what I'm trying to get across with this presentation is that we are starting as QSs. We cannot just stay within our little zone of the 5D and expect that everything will be given out to us in a lovely little neat bow that we will end up having. We just press a button. I think that's one of the main misconceptions of the quantity surveyor, that he presses a button and ultimately the information gets spitted out to him and he can produce the cost estimate on it. We need to be engaged at the very early stage with the 3D process in terms of what design information is coming out, what format it will be in, how can we read it in our softwares like CostX or any other costing softwares that we have. And also we need to kind of continue that on through the 4D facility or time element of it, where we can actually embed time information or scheduling information or logistical information that will feed in ultimately to the prelims documents that we produce, or indeed to the estimates that we produce if our estimates are based on first principles and the rates that we build up in terms of the time it will take to produce all of these elements of the build. So we need to be involved in this stage too. And again, I kind of see as well, if we do life cycle costing in terms of sustainability, you'll be looking at deriving the carbon, the embodied carbon calculation within it as well. So that's another strand. It's not something that's massively come on stream, but it is something that is there that we need to be cognizant of. So why do we need BIM? I think anybody that's ever gone to college has read Egan, Latham from a construction perspective and construction degree, and generally speaking, the whole idea behind the Egan and Latham reports was a damning report on the construction industry. To my mind, it was very much a notional study that they could basically give a roadmap or a point to get through the current mire that they were in around the kind of early 2000s, and that, you know, comments like the task force doesn't consider technology on its own can provide the answer to the need for greater efficiency and quality construction. I think the idea behind of rethinking construction was really to get people on board, to change their processes, to change the way they go about doing construction, to make it more streamlined, and ultimately to improve the finished product. Similarly to the way they've improved the finished product in manufacturing, the automotive industry, we were always, as construction industry, we were always held up in comparison to them. We didn't come in favorably. I'm not saying that everything that Egan and Latham and further reports Farmer has been implemented, but I think there is a shift in the industry at the moment, and you can see through the title of the Farmer report of Modernise or Die. You know, the Egan and Latham report used language that was more in keeping with this aspirational BIM policies that are out there, whereas now Farmer has kind of grown up, and it's 2016, and Modernise or Die means that we're getting there. We're implementing the systems, and if we don't implement the systems and we don't become a more collaborative, streamlined workforce, we will ultimately die or be left behind, as the case may be. Why also do we have project data, or why also do we use BIM? With BIM, with any other process, we have a load of data that is given to us. So if we look from left to right, all the data is given to us in the various different formats. What do we need to do, or what are we looking to do with that information in order to improve our processes and ultimately achieve a greater cost, time, and quality outcome for our projects and improve the deliverables of our projects? So what do we need? We need to be able to understand it in order to unlock the data potential. Once we've understood it, we need to integrate it within our systems and within our workflows to improve our scope, costs, and scheduling information that's being delivered to the client or to any other stakeholders that are there. Once we have that information delivered in the correct format, we can then make data-driven decisions, which should be, with the benefit of hindsight and having all the information stacked together in an easy readable format, should make our decisions better and should ultimately improve the workflows or the project outcome. Once we've done that, a construction project is over, we got the digestible data here that we can bring out and understand, and ultimately bring through to compare the trends and analyze where the market is going. It's obviously important at the moment, given the volatility of the markets that we're in at the moment, that we compare, we analyze, and we understand where things are going. I think the benefit of it is if you improve these systems here and you streamline these systems and you capture the information in a much more succinct manner, it will allow you a lot more time to look at these items here, the data-driven decision-making, digestible data, and ultimately compare the trends analysis to give you a better overall system that you're working with that hopefully will achieve a project to improve your project's outcomes. So in terms of time, cost, and quality, projects needs to be defined always in time, cost, and quality to have for a number of years now at this stage. And traditionally, compromise was seen as the only solution to achieve the desired outcome. If you look at the diagram over on the right-hand side, you've got quality, and a byproduct of quality is a good specification product. Byproduct of cost is obviously cheap or cost-effective solution. Byproduct of time is obviously, you get it done faster, and you get everybody happy because they're in the building that bit quicker. When you have quality and when you have time, the unfortunate reality at the moment is you're looking at an expensive build. Whereas if you've got quality and cost together, you're looking at a slow build, and ultimately with cost and time together, you're looking at cheaping on the specification and cheaping on the quality of it. So we need to be able to be in that utopia. And can BIM help in that utopia? I certainly think it can go a long way to trying to achieve that. I don't know whether at this moment in time, given the obstacles and the barriers that are there at the moment, we can say it will fully achieve that, but certainly it will go a long way to achieving those aims and goals, as I'm about to show here with the processes that we have included in our workflows on a day-to-day basis. So it is imperative of me at this stage, when we look at the BIM workflows and what we do on a day-to-day basis to achieve time, cost, and quality, to say the age-old phrase of rubbish in, rubbish out. If the information that we are getting from our designers is not of good quality, that we are able to disseminate the information and use it in a readable format, and it is accurate and correct, then there's no point in us doing the BIM process. So we need to have confidence in our measure, use our 2D inputs that are there in order to basically look over it and make sure everything is correct, and use the tools at our disposal through Navisworks. If you look at interrogating the model and making sure all of the different systems are in the correct place, even looking at it from a clash detection point of view, whereby it's a lot easier to resolve a clash on a piece of paper, on a piece of computer software, than it is to be standing there in the field scratching your head going, we need to work around this, which will obviously cost money, time, and ultimately the quality of it as well may well be impacted. So the first port of call in our workflows is to interrogate the model and make sure that the information that is in there is correct and is usable for us. In terms of a 4D element of it, we obviously are used to Navisworks, Synchro, Fuser, these types of tools that will allow us to create detailed schedules and construction sequences. So, it's interesting for us to embed the time into the elements to allow us to take account of the time that is required. And from there, from a costing point of view, from a QS point of view, we can develop up from first principles the rates that we require based on the information that is in our 4D model. The advantages of 4D BIM, obviously the 3D visualization of the construction process. You have much greater understanding of logistics of the project, so you can see deliveries and things like that. And then additional simulations can be performed with the model to perform a number of different scenarios. So solar shading and the like, and there are a number of different add-ons that you can allow to this software to enable you to see the various different scenarios and running through. In terms of the 5D costing, and I'll get to kind of the worked examples in the videos in a second to show you how we capture the information, but it's driven from the 3D model data. You can extract in an automated process to provide quantities and rates for use in the cost estimates. But again, I can't stress enough that we need to, as QSs, be involved in the very early stages of the job in order for the information to be coming out to be in a proper format for us to work on. So it should be faster takeoff. It should allow for better interrogation of the project estimate. And obviously that is of paramount importance in the current market at the moment, given the way costs are going and given the way lead-in times and such like are going. If you can take away the quantification process and streamline that a little bit, it will allow you more time to interrogate the model and get a better understanding of your project. And also can't be misunderstood the quantification of complex design options. As we push the boundaries of engineering more and more, you know, very few straight lines being done anymore or flat surfaces. So it is good from a QS perspective that we have that ability to have the complex quantification. So I'm just going to show you a video. It's running in the background there, and I'm going to talk over it of how we create the model maps and how we get the information out in a quick fashion. So we're going through the various different elements of the build, and we can see it in isolation, and we can see it as part of a reference model or a ghost model against it. So we're now kind of moving into the model maps, and you can pick on individual components of the model. You see it there in the element tree, doors, floors, and such like. So I'm going to look at the floors. Traditionally, you know, on a small job like this, it wouldn't take you that long to take off the volume of concrete on the floors. But if you had a number of different floors, we can imagine there's a 10-story building or something like that. It is a considerable amount of time to individually create the volumes for each floor. So what I'm doing there is I'm creating a folder and dimension group structure. So I'm running through all of the different systems, and I can give sub-levels based on that kind of backslash there that allows me to subdivide it down into the various different levels. So level 3 in this instance would deal with the description of the concrete floor that you were dealing with. If you had various different ones, it would split up the estimate in the various different sections. So I'm just appending the area and the volume calculation that's in the database, or sorry, in the columns that are there. And you can see almost instantaneously it has come up with the volume of it, but you also see the area of 210 square meters is attached to it as well. So if I look at the doors as well, we're going to get a count on the doors. You'll notice on the right-hand side, there's a fire rating, which is in yellow. The reason for that is because it's user-defined properties. So you've got a number of different classification or measurements systems that you need to adhere to, and they need to be classified in a certain way. If the information isn't in the model, you can apply that information in terms of the fire rating, in this case, and classify them as such. The process involved in it is you can export out the information that's in that tabulated format on the right-hand side into Excel. And then within Excel, you can create various different columns that will allow you to put in whatever information you want, which in this case is the fire rating. You also have the ability of just creating custom quantities there, and when you can look at the custom name. The painting of doors, if that's the quantity that we so wish, is obviously not included in the model, but we can use the data that's there, in this case height by width by 2, in order to give us the area of doors that are painted, and that can obviously be calculated as part of the quantity as well. So I suppose what I'm trying to get across is not everything needs to be modeled or embedded within the cost plan, or sorry, within the model itself. We can actually take information out as well. So I purposely left that error in, because what it is, I just wanted to showcase that it's not a situation that you press a button. You need to be able to manipulate the information that's coming out. And if you see now in a second, when I hover over it, you'll see that the painting of doors is 13 million odd square meters. That's obviously incorrect. And the reason it's incorrect is if you scroll over to the right-hand side again, and you see the widths, the number there is 813. Now that represents 813 millimeters, but in the program itself, the base unit of measurement for the project has been set is in meters. So that represents that figure of 813, and consequently the height of 2,134 as 2,134 meters. But what I've just done there is I've changed the unit to represent it as millimeters. So the base unit of measurement remains the same as meters, but the millimeters is now the quantity that's been derived from that column, which 2,134 is obviously 2.13 meters. And then when we bring it in, it obviously gives us the correct quantity there and gives us the correct dimensions to be used. So I'm just importing in the dimensions from the model map. I've just done 2 quick ones in terms of the volume and the count of the doors, so you can see how quick and easy it is to get the information in there. But obviously, as I said, with a caveat that if we don't put in the proper time to interrogate the model and understand the model, the information is going to come out is going to be wrong, and you're going to be in trouble with your estimates. So that's the model maps come in there, 67 cubic meters in the volume, and the door quants as well. You'll see the fire rating has been individually, so you can split it out. I've had jobs in the past where we looked at phasing, where you can put phasing into the Revit model. So you want to have the various different phases split up into the cost estimate, and you can get that fairly quickly by just putting the subdivision of the folders. The last video I want to show is the QSID. So the basis of this is a QSID, again, will allow you, through the use of user-defined properties, to append both a description of what the information is, be it a floor slab, a column, or whatever, and also apply a rate code to it as well. And that rate code can be sourced from an inbuilt rate database that you either create or you import from an external source through an XML import. I'll just quickly run through in terms of the model maps that are being created. It'll flash through in a second. Okay, so it's important with the, if I click on this one here, you can see the folder has been occupied by the QSID and the dimension group has been occupied by the rate code. The reason I do that is because when I go to create a workbook and I import in the model map information here, and show all items to make sure I can bring in all the information in the model map. So I'm just going to let this run through in terms of the model map. Okay, so that information is coming in and being imported. So when I create the workbooks now, it is looking in the rate column for the rate code that I have appended to it. And then it will ask the computer system or the software system to go and find that rate code within the default rate library that I have specified. And once it has done that, it will automatically populate the rate to whatever it is you have in your default rate library. So you can create estimates in this fashion, but a lot of work will need to go into actually creating the QSID codes and the rate libraries to have it in a format that you can basically create this automated process. So the last step on it is to generate using the dimension groups. And if I append on the default rate library, which is module 8, which is the CostX system, you can see we go OK on that, and it will automatically populate it, and it will automatically populate the rates onto it as well. So you can see the processes are, if you get them right and you get the information in there, the process can be a lot more streamlined and leave you a lot more time to look at your rates and look at your quantities and look at the various different elements that a QS can look at. So that's that video there. We move on to the next slide. The last slide that I have on is quality. And I'm looking at quality needs to be embedded into the 3D design phase. Data quality initially needs to be put into the models at the very early stage, and any missing elements to be highlighted. And we need to maintain that quality throughout the use of throughout the project lifecycle or construction process through the use of, we've used field apps a lot, BIM 360
Gearoid,
field. Yeah.
Sorry to interrupt. Is that okay to wrap it up?
Yeah. We're going one last one.
Yeah.
That's okay. We'll finish up on that. That's perfect.
Okay, thank you, Gearoid. And without further ado, Andrew, you've got the ball.
Okay, I'll just share my screen. You see that?
Yes.
Okay, great. So my name's Andrew Bellerby. I'm the Managing Director for Solibri's operations in the UK, Ireland, and I'm going to talk to you a little bit today about quality assets, quality data, it starts with you. And I think the previous two presentations.
Gearoid, sorry, would you mind just stop sharing your screen, please? Sorry, thanks.
That's okay.
Sorry, Andrew, thanks.
Okay.
So there we go. Yeah, that's fine.
Okay, so Solibri, probably the first company to bring quality control, quality assurance to the construction industry with regards to BIM digital models. And I think the previous two presentations have set this up quite nicely for me. Solibri actually started many years ago as a company that were providing quantity takeoff services and developed a program that did that directly from the IFC files in much the way that you've seen in the last presentation. But we actually found very quickly that the quality of the models wasn't good enough to rely on the data. And that was when we started to evolve the software at that time into model checking software. And since then it's grown and grown into a much bigger animal, looking at all sorts of different checks that you can do, which we'll cover some of today. So just the corporate part first. Solibri is part of the Nemetschek group, large German software group of software companies, around 15 brands, some of which you can see at the bottom. Probably one of the lesser known brands when you consider Autodesk, Bentley, Trimble, but Nemetschek is also widely used around the world. And some of the logos you'll recognize at the bottom: Graphisoft, Bluebeam, Vectorworks, etc. So why BIM quality assurance, and certainly why now? I'm sure everybody's aware of the recent building safety bill that's introduced and the golden thread, which is being talked about quite substantially at the moment, and what that actually means. So the golden thread of information will mean that there's going to be transparency all the way through the design, construction, maintenance and operations phases. It also means there's going to be responsibility and accountability for what's been designed, what's been manufactured, who's installed it, who's maintaining it. Essentially, there is no hiding place as we go forward. And obviously, much of that has come from the Hackett report and what happened at Grenfell, and the need to make sure those type of accidents don't happen again in the future. So I'll jump through some slides, try and claim a bit of time back, but why is BIM quality assurance important? It's been talked about, the time aspects, the money aspects, and having a clear scope of work to deliver quality. And obviously, there's talk about the impact of cost on quality. But the more quality we can bring to a project, whether that's through the design phase going into construction, the more we start to realize things like the CO2 reductions, corporate social responsibility issues. And it's only if you've got a quality design and a quality build that really starts to come to fruition. So if we have a look at what's in a digital model, it's essentially a collection of data: geometric shapes, locations and spaces, components, objects, families, relationships, etc. That must conform to standards, protocols, regulations, building codes, best practice. There's a lot of information in the model. So how do you check all of that? It's pretty tough, and especially as processes are changing. People have moved from 2D into 3D. The clear processes that were there before are not necessarily there now, and roles have changed as well, which all has an impact.
Andrew, sorry, this is Elenia. I was just letting you know that you actually have until 2:05 to speak, so no need to rush, okay?
Okay. So what do we mean by BIM quality assurance? It's certainly not just clash detection. Obviously, that's a key part. Call it clash detection, clash prevention, design coordination. It's a key part of BIM quality assurance, but there's much more to it than that. Data validation has been touched on in the previous two presentations. That's becoming hugely important as we go forward. But how do you check items that don't physically clash? How do you check deficiencies in the model? So what's missing from the model? How do you check that compliance with building codes? And actually we're working on some projects at the moment about automating building code checks and actually realizing just how difficult that is to do from an automation point of view, mainly because many of the codes are open to interpretation. The models, geometrical models, don't often have the information that's required to deliver results. So it's been an interesting topic, but that's perhaps for another presentation at some stage. What about fire safety? How do you check for fire safety? Carbon, is my design compliant? So there's lots of things that need to be taken into consideration when you think about quality assurance, quality control for your digital models. And we are really moving from data to making decisions. So you can only make decisions such as scheduling, cost information, facilities management, planning, all those sorts of things, if the data has been validated, if it has been checked. And that's kind of what Solibri are doing. We sit in actually throughout the design process, from architects, engineers, main contractors, QSs, building owners, information managers. It's a software really that's used at all the different stages to try and guarantee quality information is passed on at each stage. So if we look at quality assurance in design, then what does that actually mean to the designers, to the architects, to the engineers and people like that? And I'm going to just show some typical use cases that there may be. Solibri, as a model checking engine, we provide different templates, around 50 different rule sets that allow you to configure and combine different rules to give you answers to logical questions. So some of those things I mentioned, obviously clash detection, not the whole part of model checking, but still a key part of it. So yes, of course we do that. Most softwares do their own clash detections. But perhaps things that you don't see. So in this example, the smoke exhaust vent is located at the emergency route too close to the stairs. So it's not a physical clash, it's more a compliance issue there. The smoke vent is too close to the stairs, which isn't acceptable for a compliant design. Components, this one is actually checking the structural elements and do they actually confirm design-wise. So the opening for the fresh air grill is not exceeding the required distances from the edges, but the opening is not within the acceptable limits. So there could be a structural issue there in terms of that type of item. Typically, you might pick these up later on in the process, but this is an automated way of doing the checks. When you're looking at things that don't particularly clash, so checking distances between doors and other components. So common issue we see is people try to open the door, but there's something in the way. So in this case, the electrical conduit and the lighting fixture are in front of the door. It could be a suspended ceiling that we've seen in front of the door in different cases as well. So it's important that these type of issues can be checked. Missing components. What happens if you want to actually check what's not in the model? So in this example, we have three rooms that should be identical. We've got data sheets for each room in a hospital, but in one of the rooms, there's a chair missing. Okay, it's just a chair rather than important equipment, but it allows us to check against different data sheets to really ensure that all the equipment is in each room if it's required. And that could obviously be applied to many different cases. Perhaps other things that are more to do with the automated building code checks, accessibility. So in this example, a hospital, you can see there's actually quite a lot of rooms that have been highlighted because they don't conform to, in this case, requirements for turning a wheelchair around. So what we're doing here is we're projecting the toilet and the basin down to the floor. We're checking it against the diameter of the turning circle of a wheelchair. And then you can start to see, well, does it actually comply with the regulations? Is it a compliant design? And then what we're starting to look at more recently is things like fire safety and fire stopping, working with some of the large contractors and fire design companies in the UK. We're trying to automate the process of checking for builders' work holes and actually realizing that it's quite a complex issue when you actually come to solving these type of issues. So some of the checks we're doing, the position of the hole in relation to each other, the positions of the holes in relation to the edge of the slab or the wall, the positions of the surfaces within the builder's work holes, and that all gives you different challenges with different types of pipes, require different tolerances. The type of flow through the pipes can affect it. There's all sorts of rules that go into what is actually a really complex issue. So these type of problems are things that can be automated and really difficult to check. It's a major issue for a lot of the contractors, a lot of the designers, the MEP companies that need to look at those sorts of things. But other rules that we use in the fire safety side of things, so compartmentation, in this case, the design isn't compliant, it's not enclosed. We can look at egress in terms of the shortest route to the nearest fire exit. And then you could even go and say, well, is the fire exit, if I can't get to the closest fire exit, then is there a window that's nearby? And if there is, then what's that drop down to the floor? There's all sorts of really complex things that you can write into the rules. Sometimes we're asked to, well, can we check things that aren't in the model or aren't even modeled at all? So a recent rule that we've created, a stud opening rule, checks for clearances for surfaces above doors. The studs around the door frame aren't typically modeled. So what we do when we run the rule is we temporarily build these studs into the model, we do the check, and then the ghost studs are removed again from the model. So it's really a smart check for for things that you perhaps wouldn't pick up in a manual check. And then other things, door leading edge rule again is another new one. This one checks for clearances and interferences with door openings. The door openings, we know which way they're open because the information comes from the IFC file. And that's been developed as part of a digital compliance project that we're working on with a number of other educational establishments and interested parties as well for automating building code checks. So we've looked at design. Obviously, there's many stages throughout the construction process. So what about quality assurance in manufacturing? Well, we have a few nice examples of that. And I guess we didn't really anticipate that Solibri would be used in this way, but our customers always surprise us in terms of how they use the software. And Langer O'Rourke's an example of that, where they've actually taken Solibri, some of the rules that are there in Solibri as standard, and being able to check, can these precast concrete parts go to the carousels, the automated machinery? Are they, are the dimensions correct to fit the machines? And that allows them then to guarantee that their manufacturing process is correct. You can imagine with precast concrete parts, if it's wrong, it gets to site, then another part has to be cast and delivered to site, and that can take a couple of days to get that there. So ensuring it's correct before you go to manufacturing is also a key part of the process. And then you move through into the construction phase. So what we're looking at here is, it's been touched on getting accurate quantities and information from the models already. You can only generate that if you've validated the data in the model. So it's key that you can get that information from the model, but it's also key it's been checked, it's been validated. So one of the most common issues we see is multiple instances of the same item in the model. And we've seen as many as 25, 26 columns in the same place because somebody's tried to copy it and they've actually copied it on top of each other. Not easily picked up by clash detection software, but that can affect your quantities hugely. So it's a key part, making sure the model is correct, the data within the model is validated, and then, as has been touched on already, it can be used further down the chain. Another thing I wanted to touch on is on construction site, does the as-built match the design? So Nemetschek have recently invested in a startup called Immerso, who have developed quite a nice, simple tool, cloud-based, that you upload your digital model, you upload a scan that you've done for the building, and it will then do a comparison of the as-built versus the design. So it's looking for tolerance checks. You can see on this image on the left that the services aren't passing correctly through the builder's workouts, as we talked about with the fire stopping before. It will check for deviations in walls and slabs, and it will report that back to you. But quite nicely on from that is the ability to then actually pass the information in two directions. You can create a BCF, a BIM collaboration format, quite a common way of exchanging issues now between check-in tools and authoring tools. So it can be pushed to the authoring tool for resolution that way, but they can also update the BIM using an updated IFC file. So pass that information back again to the authoring tools, or quite a nice workflow that we see is passing it back to Solibri. You can recheck knowing where the as-built is, and do you still conform to those checks that you've done in the design stages? Is it acceptable, or does it need addressing? So you can now get quality on site as well. Quality assurance in handover. Validated data equals better decisions. I think that's become clear. So there's been a lot of talk about classifications on the previous presentation, so I'm not going to talk too much about them, but it's just different ways of breaking the model down, whether it's by element, whether it's by system, whether it's by unit class, whether it's by phase, building, whatever you want it to be, and then using the data from that. But again, as we've said before, when you go into things like COBie, you need to ensure that information is correct. I was talking with a customer of ours, it was actually a couple of years ago now, about he'd been asked to audit a COBie submission that had been provided for a final handover. And when he did the checks on what was supposed to be completed and issued information, he found more than 2,000 errors in the file, just because the data has not been validated, it's not been checked. So how do you rely on that data for making decisions? You can't, you're guessing. So we said at the beginning, quality data, it starts with you. When we're talking to a lot of people in the industry, I said before, there's various things that come forward. What's the driving force? What compels you to make that change and introduce different ways of working, whether it's implementing BIM or something else? We said before, some people, when you talk about quality assurance for BIM, we do check our models, we do design coordination. That's only a small part of it, as you've seen today. Clash detection tools have been around for a long time. We still get far too many issues on site that come from issues within the models. It's not our job, or we'll do it when we're told we have to do it. It's something that we hear all the time. We saw with the government mandates that forces people to use BIM and to start delivering COBie, for example. Unless people are told they actually have to do something, they tend to do, I won't say as little as they can, but there's excuses there for not providing a quality product at times. But pride in your work, company reputation should be a prerequisite. We see a lot of people who don't like it when you criticize their model. The model looks fantastic. We rarely see a model that we can't find something wrong with. In fact, we've never seen one. The amount of data within a model, it's impossible to check everything. And what we're trying to do is automate those processes. There's always a multitude of errors there. Okay, well, I'll jump to the next one. So I said before at the beginning, quality data, quality assets, it starts and it also ends with you. There's so many reasons why you should be checking the quality of your models, checking the quality of your design. And, just a few examples there. But at the end of the day, yes, it saves money, it reduces carbon, it saves time, it saves lives. It should be a no-brainer. Thank you.
Thank you, Andrew. Very, very good. You're right on the button the time we gave you. I think I've been looking at the chat box, and I think most of the queries there have been answered by the presenters already. Am I making a mistake in that? No? Okay. Well, look, if that's the case, all that remains for me to do is to thank you, Andrew, and also Robin and Gearoid for your presentations. They'll certainly pay to revisit them once we have circulated the presentation, the recordings. The only other point I want to do is thank the sponsors, Solibri, Arup, and Linesight, for their sponsorship. And I also have one final task. We have our Tech Live conference coming up very, very shortly. It's kind of special for us because it's going to be spread over 3 days. The first day, it's a lunchtime presentation. The second day, the same. And the third day, we're going to meet face-to-face in the Gibson Hotel. This is the first face-to-face event we have had since COVID. It's a long, long time ago, but the Gibson Hotel, if any of you who have spoken there, it's actually a very good place, a very comfortable place to have a conference. So I'm looking forward. We'd appreciate if you could support this and maybe tell your colleagues about it. We have an excellent bank of presenters that I think will give a very, very good outcome to the session. And with that, I'm just going to thank you again, you and all the participants and everybody who dialed in. We appreciate your business and we let you get back to work. Thank you.